Okay, hello everyone. Okay, welcome ulit sa ating next exercise. So this is the influence of nitrogen content of organic matter on ammonia formation. So it has to do with the CN ratio of the organic material. Okay, so kapag high yung organic material, ay high yung CN ratio ng organic material, what do you think would be the effect on ammonia formation? Will it increase or will it decrease? Okay, so for the overview, the carbon-nitrogen ratio of organic materials is a convenient tool for predicting the rate of decomposition and regulating the quantity of mineral nitrogen available to plants. So therefore, you have to be familiar with the nitrogen cycle. Okay, so you have to be familiar with the processes uh, that involve nitrogen transformation, mga fixation, immobilization, mineralization, leaching, and so on. Okay, organic materials with wide CN ratios of 30 or 1 is to 30, 30 is to 1, sorry, like mature corn stalks, have relatively slow rate of decomposition. Kasi lumampas na siya dun sa 25 is to 1, which is the ideal CN ratio. And when applied to the soil, result in a lowering mineral nitrogen because microorganisms mobilize the nitrogen. So, yun nga, if the CN ratio of an organic material is high, there will be immobilization. Okay? Now, when the CN ratio is narrow, there is mineralization naman. So, mineralization will predominate and nitrate level will increase. Okay? So, mag-base doon sa CN ratio ng organic matter. Okay, so I will be grading you with the objective, fill it up. Okay, and then for the materials, just read. Okay, we have soil, ground rice straw, peptone, potassium chloride, 10%, sodium hydroxide of 40%, 2% of boric acid, and then indicator, and then a standard sulfuric acid. Wide mouth jars are polyethylene bags, flasks, graduating cylinders, funnels, filter paper, burette, or mga laboratory apparatus. Now, for the procedure, babasahin ko pa rin ha. Okay, weigh 150 gram portion of the soil. And then add 1 gram of peptone. Weigh to the nearest 10 milligram or 1 gram. And then add ground rice straw as follows. So, dun sa, okay, so parang ano to? Study 1, 2, and then 3, 4, and then 5, or ano ba to? Bottle of 150 gram of soil plus peptone plus no rice ground straw. Tapos doon sa next, 150 gram of soil plus 10 milligram of peptone and then plus 3 gram rice straw and as follows until 12 grams. Okay, so you have your control there. Now, after making additions, mix thoroughly and moisten the soil carefully. Not too wet. Okay, moist lang. Weigh the crack and maintain the weight by adding water every laboratory period, then incubate at 28 degrees Celsius. Now, as soon as the experiment has started and after 7 and 14 days incubation, you take 10 gram samples and then determine its moisture. Next is take 20 grams for you to determine the ammonium content using KCl extraction method or yung Kjeldahl method. So for the ammonia determination dito sa ammonia determination, yung 20 gram na yon, you place it in a wide mouth bottle, add the 50 ml of 10% potassium chloride and then shake for 30-minute period. Then filter through a folded filter paper. So, kunin ninyo, you filter yung solution na yon. And then, kunin ninyo yung filtrate, no? So, yung filtrate, it must be clear. Okay? Bakit clear? Kasi gagamit kasi kayo ng ano to? Ano nga ulit to? Gagamit kayo ng indicator, okay? So, kailangan yung filtrate ay clear. Now, take a 10 ml portion of the ammonia determination, place it in a Keldal distillation apparatus, and then add 5 ml of 40% sodium hydroxide to distillation apparatus. And then observe. Okay? Observe niyo kasi doon mangyayari yung liberation of ammonia, or doon mangyayari yung parang volatilization. Okay, now, kasi ang inaaral natin dito is yung ammonia or yung formation of ammonia. Distill the ammonia and then observe it in 10 ml of 2% boric acid and combining a pH indicator. So, when you distill kasi, it is when you separate the component from a liquid mixture by boiling and condensation. So, in distillation, there is the production of the gas product. So, doon na naproproduce yung ammonia. Okay? So, there will be the ammonia formation. And then, distill over about 50 ml and liberate with standard sulfuric acid. So, I will be attaching a YouTube video link. Please watch that one so that you can relate doon sa Geldal process of determining ammonia. Okay? So, hindi kasi natin to gagawin, no? Tapos in-explain ko pa. Okay? So, you have to be aware din kasi, malay natin in the future para at least may idea kayo. Okay? So, syempre, wala tayo kakalculate, but if ever my data, calculate the ammonia in milligram per 100 gram of dry soil and in percent of the total added organic nitrogen. Calculate the carbon-nitrogen ratio for each mixture of straw and peptone. And then, why does the straw decrease the yield of ammonia? Okay, so nandyan na yung clue ha. Again pala, dun sa Geldal method, ang pwede kasing i-analyze using that method is yung ammonia, ammonium, and then total nitrogen. Okay? So, meron kasi yung iba is, yung ibang method, you can analyze others pa. Pero pag Geldal, ang ma-analyze mo dito is yung ammonia, ammonium, and total N. Kapag yung isang process, I forget it, no? Pero ang kaya namang i-analyze doon is yung nitrite, nitrate, and then yung na-analyze din ng Geldal. Keldal method. Kaya broader yon yung isang yon. Okay, so going back here, why does the straw decrease the yield of ammonia? So yun nga, as you increase the amount of the rice straw, okay, you are decreasing the yield of ammonia. Therefore, in here, alam na natin na for this battle, okay, sa letter A battle, alam na natin na there will be a decrease of ammonia because of the addition of rice straw. Okay? So, if dialysis were made after a long period or incubation, would the same difference be observed? So, ano ba yung dialysis na yun? So, it is like dun sa, ginagawa din sa hospital, no? Yung dialysis na yun. So, this is a process of separating molecules in solution by the difference in the rates of diffusion through a semi-permeable membrane. So, it is to remove the salt concentration from a solution. So, kapag naman sa dialysis na ginagawa sa kidney is, it is to remove whatever, salts. Ganun din naman kasi, ganun naman talaga ang ginagawa ng kidney, di ba? Nililinis, okay? Nililinis yung blood. Okay? So, tinatanggal yung impurities doon. So, ganun din yung nangyari dito. Okay? So just read. You read this one, no? I recommend you to read this one kasi makakapulot kayo ng sagot here. And then for your exercise number 5, of course, you are not going to do this, pero alam na ninyo yung result ha, na kapag 0 or dun sa control na walang rice straw, okay, there will be mas malaki yung amount na ammonia, ng ammonia na na-produce. And then kapag increase naman, lower yung ammonia na na-produce. Okay? So, ayan. So, just answer these study questions. No? So, knowing the results from the experiment, what is its significance in nitrogen management for crop production? Okay, ano ba yung result na sinasabi natin kanina? Yun nga, one is yung ito, kapag nag-i-increase ka ng organic matter tapos with high CN ratio pa, yung ammonia formation will decrease. Okay, what is its significance in nitrogen management for crop production? So, i-relate ninyo in practical situation, okay? So, ano yung significance na? Why does the straw decrease the yield of ammonia? So, bakit? Okay? So, i-relate ninyo doon sa CN ratio content ng rice straw. Di ba mataas yon? And then, why is nitrification a slow process soon after the incorporation of organic residue? Okay? So, another process, process of nitrogen transformation, no? Nitrification. So, bakit? Yun lang naman ang mga questions. Now, I will include this one. Allow me to include this. Okay? In the discussion. So, the nitrogen basics, the nitrogen cycle. Ito mate. Okay, so we have here, in the nitrogen cycle, we have here the different processes, no? There could be fixation, mineralization, nitrification. So, bakit sila hiwalay? The nitrification, volatilization, immobilization, and then leaching. So, the nitrogen cycle here illustrates how nitrogen from manure, okay, fertilizers, and plants moves through the soil to crops, water, and to the air. Now, understanding the nitrogen cycle will help you make the best use of manure and fertilizers to meet crop needs while safeguarding the environment. So, hindi lang ito basta-bastang experiment. In every experiment kasi, we have to correlate it with the real situation. So, in general, the nitrogen cycle processes of fixation or all these processes, okay, result in permanent or, ano ba yun? Sorry. So, result in whether increase plant available nitrogen, so gaya ng tatlong ito, 3 processes, or it could result in permanent or temporary nitrogen losses from the root zone. Okay? So, first is, so ayan ha, with this, there is the increased plant available nitrogen. So, as we have said, kapag sa mineralization, when there is, when there is a high CN ratio, of course, immobilization will occur. So, microorganisms will immobilize the nitrogen. So, yung nitrogen, it will not be available. So, dito. Okay? Immobilization na to. So, yung nitrogen, it is not available for plant. Pero, of course, maging available din yun soon. Kaya nga siya temporary. Now, kapag mineralization naman, um, it will increase the nitrogen availability. So, ang focus kasi dito is mineralization and immobilization. Although, we cannot exclude these other processes no, of nitrogen transformation. Okay, so again ha, yung fixation, memorize this, yung lahat ng processes that are involved in nitrogen cycle. So fixation, yan nga, the conversion of nitrogen gas into a plant available form. Okay, so yung dinitrogen to available form. And so just read, okay, industrial or biological process. We have just discussed this. And then next is yung mineralization, where microbes decompose organic nitrogen from manure to ammonium. So mineralization is also ammonification and also decomposition. Kasi when there is mineralization, the process that is involved there is decomposition also. And then yung end product is yung ammonium. So, mineralization is almost equal with ammonification. And there, mineralization occurs in warm temperature and well-aerated and moist soils. And then, for nitrification, okay, this is biological because it involves microorganisms. So, it converts ammonium into nitrate to obtain energy. So, for the microorganisms to obtain energy, okay, they have to convert these nitrogen forms from ammonium to nitrate. Okay, to nitrite and then to nitrate. And this is most rapid when the soil is warm, moist, and well aerated, but is virtually halted below 41 degree Fahrenheit and above 122 degree Fahrenheit. Denitrification occurs when nitrogen is lost through the conversion of nitrate to gaseous form of nitrogen. So, such as conversion of nitrogen into nitric oxide, nitrous oxide, and then dinitrogen gas. So, basta yung ang end product is a gas. Okay? Umulan. And this is common in poorly drained soils. And then volatilization, end product is ammonia. Okay, so the conversion of ammonium to ammonia gas. Immobilization, of course, the reversible process of mineralization. All living things require nitrogen, therefore microorganisms in the soil compete with crops for nitrogen. Immobilization refers to the process in which nitrate and ammonium are taken up by soil microorganisms and therefore become unavailable to crops. So, ayun nga, the microorganisms have took up the nitrogen, so it has immobilized in their system. And then leaching, so included din ang leaching no in nitrogen cycle. Okay, and this happens right after nitrification. Okay, kapag na-convert na yung nitrogen into nitrate and nitrate is easily leached. And then of course crop uptake also. Part siya ng immobilization. No, natin. Yeah, kasi the nitrogen is immobilized by microorganism. By plant, sorry. Okay, so to make the most of existing nitrogen sources and purchased fertilizers, so ito na nga yung in practical situation, no? Consider the nitrogen cycle facts below. So the timing and method of manure and fertilizer applications determine the availability of nitrogen to the crop, but also its potential losses. And then, during dry seasons, with immediate incorporation will conserve ammonium from volatilization losses. Cover crops act as a nutrient savings account by taking up residual nitrogen from the growing season of previous manure applications and thereby reducing leaching losses. The nutrients in the cover crop become available for the next crop by mineralization after the cover crop is rotated. So, nandito na yung clue ha doon sa mga study questions. Just read and then understand. Okay, I will not tell you, pero nandyan yan. That is why sinama ko ito sa discussion. Okay, and then of course, so that is yung CN ratio, that involves yung CN ratio ng organic material. Here naman, yung sa soil microorganisms. Okay, so, ang CN ratio ng soil microorganisms ay 8:1. Okay? So, but yung diet for the requirement, CN ratio requirement must be 24:1. So, ito nga, this is what governs the soil. Yung CN of 24:1. Ito yung normal dapat. So, with this 24:1 kasi, yung 16 parts of the carbon there is the source of energy for microorganisms. And then yung 8 parts ng carbon is the necessity, is the, ano ba? Ito naman yung part na need ng microorganism for body maintenance. Okay, so it has to maintain yung 24:1 CN ratio diet of the microorganisms. Now, when there is a high CN ratio, okay, kapag high CN ratio yung organic material, immobilization will occur. So, microorganisms will tie up the excess nitrogen. And kapag there is low CN ratio, there will be mineralization. So, the decomposition is fast and then the release of nitrogen is also fast. Now, that in low CN ratio also, it leaves excess nitrogen in the soil. While in high CN ratio, okay, no excess, pero kinukulang pa. So, they have to look for other source of nitrogen in order for the microorganisms to continue degrading the organic material. Okay? So, ano ba yung mga example ng high CN ratio? Mga rice straw, okay? Mga corn. Sa low CN ratio naman, dry corn ha, sa low CN ratio, okay, we have alfalfa, yung mga sunflower, usually yung mga green organic materials. Okay, so why am I telling you this? Kasi dito kayo magbe-base ng mga, okay, sagot ninyo. Okay, so that's it. Thank you very much for listening.